So looking at 5. For these questions, we need to write the complete linear factorization and the zeros of each of the following. So to find the zeros here, we need to do our P over Q. What are factors of our constant? Anybody? What are the factors of 8? 1, 2, 4, and 8. And then our factors of 1 is just plus or minus 1. So what number should we start with here? Let's start with 1. So in our box we have 1, 1, -6, -4, and 8. So 1 times 1 is 1. 1 plus 1 is 2. 1 times 2. 1 times -4. All right, perfect. So 1 works. So one of our factors here is 1. Now we're left with x cubed plus 2x squared minus 4x minus 8. We can do our P over Q again, but can we factor this any other way?
Grouping?
We can factor it by grouping. So we're going to group our first 2 and our second 2. What do we have in common in our first 2? X squared. So then we're left with x plus 2. And then what can we take out in our second 2 that'll leave us with an x plus 2? -4. So then x plus 2. So then we take our 2 that are outside and put those together. So x squared minus 4. And then x plus 2. So we're finding our zeros, so we need to set both of these equal to 0. So x squared minus 4 is equal to 0, and x plus 2 is equal to 0. We would add 4 to both sides. So x squared is equal to 4. Take the square root. So what do we get for x here? Plus or minus 2. And then the second one, we just subtract 2 on both sides, so x is equal to -2. So our zeros here are 1, -2, -2, and +2. So since our highest degree is 4, we know we're going to have 4 zeros. When we have 4 zeros, we know we did it right. We know we're done. How would we put this into linear factorization? Just x minus 1, x plus 2, x plus 2, and x minus 2. So this is just the linear factorization of our zeros. One thing that I wanted to mention is this group here, find the polynomial functions that have the given zeros. There's not going to be any questions like this on your test on Tuesday. So 8, 9, and 10, and I think there might be some on the next page too, but there's no questions like this on your test. So let's look at number 3. So do we have any greatest common factors that we could pull out from the start? X. So anytime we have a greatest common factor, it always helps to take that out. So we have x to the 4th plus 5x squared minus 14. Now we can see, do we have any factors of -14 that add to 5? -2 and 7. So then we can put that as x squared. Now we're starting with x squared since we started with x to the 4th power. So it's just a basic factoring problem, except now we started with x to the 4th, so our parentheses here are going to have x squared. So x squared minus 2, x squared plus 7, and then we can't forget about that x that we pulled out in the beginning. And now we can just set each of these equal to 0. and solve. So x is equal to 0 is already solved. We add 2 to both sides here. So x squared is equal to 2. Take the square root. X is equal to what? Just the square root of 2? Plus or minus square root 2. Anytime you take the square root, you have to do plus or minus. And then the third one, we have to subtract 7 on both sides. So x squared is equal to negative 7. Take the square root. So x is equal to what?
7i.
Just plus or minus I square root 7. Oh yeah, plus or minus square root 2. So now writing this in our linear factorization, we just have an x. We have x minus square root 2, x plus square root 2, x minus I square root 7, and x plus I square root 7. And then our zeros would be 0, square root 2, negative square root 2.
Good morning, Mavericks.
If we want to double check, we see that we started with x to the 5th, and our answer has 5 zeros, so we're good. Yes. Okay. So we did 14 in class, so it kind of just ran through 17, but we'll go around it. So if we have negative 2 minus 5i as one of our zeros, what's another zero? Negative 2 plus 5i, so it's conjugate. Now we write this as our linear factors, so we have x. I always like to write minus and then whatever the term is, so minus 2 minus 5i, and then x minus negative 2 plus 5i. Now I can distribute the negative in both of our parentheses here. So I have x plus 2 plus 5i and x plus 2 minus 5i. Now here we have conjugates, but our first term is x plus 2, and then our second term is 5i. So we're going to square our first and square our second. So we have x plus 2 squared minus 5i squared, which if we didn't know the shortcut for multiplying conjugates, we could always FOIL this out too, and we'd get the same thing. So it would work if we FOILed them out. So now we have to FOIL x plus 2 squared, so we would get x squared plus 4x plus 4, and then minus 25i squared. What does the I squared become? Negative 1, so it makes it a plus 25. So we combine our like terms. We have x squared plus 4x plus 29. So this is one of our factors. Once we get here, we need to divide. So we're going to divide this into our original polynomial. So we have x cubed plus 11x squared plus 57x plus 203. So what times x squared gives us x cubed? X. Now we multiply the x with everything out front. So we have x cubed plus 4x squared plus 29x. Change all of our signs. Cancel it out. 11x squared minus 4x squared. 7x squared. What's 57x minus 29x? 28x, so plus 28x. What times x squared gives us 7x squared? 7, so plus 7. You multiply 7 to everything out front, so 7x squared plus 28x. What's 7 times 29? 203. Change all the signs. So it cancels, cancels, and cancels. So we're just left with x plus 7. So what would our 3 zeros of this equation be? Negative 7. Negative 2 plus 5i. And negative 2 minus 5i. So it gave us 1. We know that if it's a complex number, the conjugate is also a 0, and then we just have to divide to find the other one. So let's take a look at 35. So for the following, find the domain, range, axis of symmetry, vertex, max and min, y-intercept, and x-intercept. So let's start with our domain. What's our domain going to be here? All real numbers. Anytime we have a parabola, it's all real numbers. So in interval notation, it would be negative infinity to infinity. Let's skip our range for now and go to our axis of symmetry. How do we find the axis of symmetry here? Negative b over 2a. So what's our b? Negative 5. So this would become positive 5 on top. And then 2 times 3 would be 6. So our axis of symmetry is x is equal to 5 over 6. Remember, axis of symmetry is a vertical line, so we need that x is equal to. Now what's the first number in our vertex going to be, our x value? Five over 6, the same thing as our axis of symmetry. And how do we find our y value? We plug in 5 over 6 into our equation. So we have 3 times 5 over 6 squared minus 5 times 5 over 6 minus 2. So 3 times 25 over 36 minus 25 over 6 minus 2. Multiplying 3 times 25 over 36 would give us 25 over 12. To subtract our fractions here, we need a common denominator. So I'm going to multiply the second one, the top and the bottom, by 2. So this now is 50 over 12. And now we can combine our two fractions. So 25 minus 50 is negative 25 over 12 minus 2. I need to subtract the 2, so again, I need a common denominator. I'm going to multiply the top and the bottom by 12. So this is 24 over 12. Subtract, I get negative 29 over 12. So our vertex y value is negative 29 over 12.
Yeah.
My bad. So this is 49. Negative 49 over 12. So if we were to graph this, our vertex is 5 over 6, which is kind of close to 1. And then we go down negative 49 over 12, which would be about 4. So our vertex would be kind of there. Is our graph going to open up or open down? It opens up because our A is positive. So this value tells you it opens up. Yes.
Well, back to the domain. So when it's always like squared, like the parabola is always all real numbers.
Yep. Anytime you have a parabola, the domain is always all real numbers. All right, now we can go to our range. So we're going back to range. What would our range be? Where does our graph start? What y value does it start at? Negative 49 over 12. Is it including negative 49 over 12? Do we put a bracket or parentheses? A bracket. So we have negative 49 over 12. And where does our graph end? Infinity. So remember, our range are our y values, so we're looking at all of these values here. Our graph doesn't start until it gets to that negative 49 over 12. And then it keeps going to infinity. All right, let's look at max and min. Do we have a maximum value here, minimum value at our vertex? A minimum value. And what is that minimum value? Negative 49 over 12. So remember, the x value in your vertex is always the same as your axis of symmetry. The y value in your vertex is always the same as the max or min. What is our y-intercept? It's got to be a coordinate point. 0, negative 2. So when we plug in 0 for x, we get negative 2. And then how do we find our x-intercept? We factor the equation, so we set y equal to 0. So this is 3x squared minus 5x minus 2 is equal to 0. Since our first term is not 1, we have to multiply the first and the last together. So this is negative 6. Do we have two factors of negative 6 that add and give us negative 5? Negative 6 and 1. So in our parentheses, we have x minus 6 and x plus 1. We can't forget that we didn't start with 1, so we have to divide both of these by 3. So this is x minus 2 and 3x plus 1. Set both of them equal to 0. So x is equal to 2, and x is equal to negative 1 over 3. So what would our x-intercepts be?
2, 0, and then negative 1 over 3, 0.
Perfect. Have to be coordinate points, so 2, 0, and then negative 1 over 3, 0. What would we do if we didn't have two factors of 6 that add and gave us 5, negative 5? Then we would use the quadratic formula. So if it doesn't factor, we would have to use the quadratic formula to find our x-intercepts. All right, so that one's 35. The question was, can we repeat how to find the range? So for the range, we're looking at our y values of our graph, So we see, where does our graph start? What y value does it start at, and what does it end at? So our smallest y value, we always start with our smallest values. So our smallest y value is here. Our graph starts at this point. So that y value was negative 49 over 12. We don't have a hole there. Our graph is including at that point, so we put a bracket. And then our graph keeps going up. So if we keep looking at our y values, our highest y value is infinity because our graph goes up to infinity. So our ending of our range would be infinity.
Did you get the y-intercept?
For the y-intercept, you set x equal to 0. For the x-intercept, you set y equal to 0. All right, just for extra practice, I'm going to work out 36 also. So for all parabolas, our domain is all real numbers. So we have negative infinity to infinity. I'm going to skip the range for now and go to our axis of symmetry. So our axis of symmetry formula is negative b over 2a. Our b is 3, so negative 3 over 2 times negative 2. This is negative 3 over negative 4. A negative divided by a negative is a positive. So this is 3/4. And our axis of symmetry is a vertical line, so we have to put x is equal to. Now for our vertex. Our x in our vertex is going to be 3/4. To find what our y is, we need to plug the x back in. So we have negative 2 times 3/4 squared plus 3 times 3/4 plus 1. Oh my gosh, sorry, I'm outside and there's a bird. So we square 3/4, so this is 9 over 16 plus 9 over 4 plus 1. When multiplying negative 2 times 9 over 16, this is 9 over 8 plus 9 over 4 plus 1. I'm going to change these so I'll have the same denominator. So multiplying the top and bottom by 2, we have 18 over 8. And then here, multiplying the top and the bottom by 8, we have 8 over 8. So this is 9 plus 18 plus 8, which is 27 plus 8, so 35 over 8. So our vertex is 35 over 8 for our y value. Next, I'm going to draw my rough graph here. So our vertex is 3/4, so almost to 1, and 35 over 8, which is about 4. So it's about there. Our parabola opens down because our a is negative. So this negative number tells us it opens down. So roughly, our graph looks like that. So now I can go back to the range. I see our graph is going towards negative infinity, so it starts at negative infinity and then ends at 35 over 8. And we put a bracket there because it's including 35 over 8. Now our vertex is at the maximum value, so we have a max here, and our maximum is at 35 over 8. So now to find the y-intercept, we change x to be 0. So this is 0 and this is 0. So 0 plus 1 is 1. So when our x is 0, our y is 1. And then our x-intercept, we change our y to be 0. So our equation 0 is equal to negative 2x squared plus 3x plus 1, and we need to factor. So we multiply our first and last terms together. So this is negative 2. Two factors of negative 2 that add to 3, we don't have them. So if we can't factor, we need to do our quadratic formula. So we have negative b plus or minus the square root of b squared minus 4ac over 2a. And we plug everything in. So we have negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times A times C over 2 times negative 2. So this is negative 3 plus or minus the square root 9 minus, this becomes a plus because a negative times a negative would be a positive, 8 over negative 4. We can simplify this again to negative 3 plus or minus the square root of 17 over negative 4. So we could leave our answer like this, or if you wanted to divide everything by a negative, this would be 3 plus or minus square root 17 over 4. So either way works. But then our x-intercept would be negative 3 plus or minus the square root of 17 minus 4, comma, 0. Alright, so that is 36. Alright, so I made a silly mistake when adding here. Multiplying this times negative 2 gives us a negative 9 over 8. So then when we combine these together, this is 17 over 8. So that changes our answer for the vertex. This is 17 over 8. The max min should be 17 over 8. And the range should be 17 over 8. So on your test on Tuesday, just make sure you're careful when adding and subtracting, because this can be one of the easiest parts, just plugging in the number and finding y. But if you make a sign error, it could change your answer in 3 parts of your answer. So just be careful when doing that.